Good day, stat students. So today we're going to go over 10.2 part 2. And so I have to remind you of something, is that the general formula for any confidence interval is the following. It's the point estimate plus or minus the margin of error. All right. And so the point estimate is going to be the center of the confidence interval. And the margin of error, if you think about it, controls the width of the confidence interval. Actually, the width of the confidence interval will be twice the margin of error. So if your margin of error is 5%, that means the width of the confidence interval will be 10%. It's going to be twice as much as the margin of error. And so the margin of error controls how wide the confidence interval is going to be. And that has everything to do with what we're going to be discussing here today. So let's start off with this, is that if we created a 95% confidence interval, that means the difference between the sample statistic and the population parameter will be less than the margin of error in 95% of all possible confidence intervals of that sample size. And that was a mouthful, but let me break it down. Okay, let's make it a little shorter here. What is it saying? It's saying that, so if we set the confidence level to 95%, all right, the difference between the, the statistic and the parameter is going to be less than the margin of error in 95% of all possible confidence intervals. Right? And so, in other words, most of the statistics is going to be pretty close to the parameter. Okay, and it's going to be um, so close that 95% of all possible confidence intervals will contain the parameter. That's what we talked about in the last section. Right? Well, you might be saying, well, why don't we just go ahead and create a 99% confidence interval? I mean, okay, so we're more confident about stuff. Isn't that good? Well, it depends, you know. So here we changed it to 99%, and that means 99% of all possible confidence intervals is going to do the job, right? 1% will not. And you're saying, well, what, we want to have that? Well, where are we going to stop this? Why don't we just make a confidence interval as high as we possibly can? So why don't we just make a 99.99999% confidence interval instead? All right. So to answer that question, I have a question for you. All right. Here's the question. Which confidence interval would be more useful to us? A confidence interval for P that goes from 1% to 99%, or a confidence interval that goes from 49% to 51%? So think about it. Which one is more useful to us, the first one or the second one? Let's see, the first one, the one that goes from 1% to 99%, heck, as long as you tell me that that you're making a confidence interval for the population proportion P, um, I don't even probably have to know how that's being defined in the problem. Because why? Because I'm pretty much almost guaranteed that the population portion P is going to be between what, 1% and 99%, and I didn't have to do any kind of study or anything, right? So clearly, the second one that goes from 49% to 51% is much more useful to us, okay? And so, and why? Because remember what we're trying to do. We're trying to home in on the value of the population portion P. We're trying to home in on the value of whatever parameter we're creating a confidence interval for. All right. And obviously, the second one does a much better job. It is limiting the amount of numbers that we have to take a look at. Okay, with regards to that particular parameter. Right. So the idea here is that, I guess the thought here is that we should then examine what would make a confidence interval was smaller, because we just saw that having the confidence interval that goes from 49% to 51% is a lot better than the one that goes from 1% to 99%. So the smaller width here is better. Okay, so what would make a confidence interval was smaller that a researcher could control, right? Well, there's two things that we should take a look at. The first one is the confidence level. Now, why the confidence level? Well, remember the margin of error is the critical value times the standard error. And the confidence level controls your critical value, okay? And so, for instance, if we change the confidence interval from, say, 95% to 90%, the critical value is going to change from 1.96 down to 1.645, okay? Now, that's for a confidence interval for the population portion P, all right? But I can guarantee you that no matter what confidence interval that you are creating, if you go from 95% down to 90, the critical value will go down. Okay, no matter what confidence interval you're creating. It doesn't matter what parameter that you're taking a look at. All right, and but there's a problem with this. Okay, the 95% comes from industry standards. Okay, and what I mean by that is that if you're working in the medical field, okay, and you're a medical researcher, you're probably going to make a whole bunch of confidence intervals in your lifetime, okay, and they do it all the time. And in the medical field, they've set on a 95% standard. They said 99 makes the confidence interval too wide, and 90% uh, we don't have enough confidence in what's going on there. All right, and so we don't want to go against industry standards just because you created a confidence interval. Oh, well, that's too wide. Let's make it from 95 down to 90. We'll go against what everybody else is doing in the industry. No. So you could do this as a researcher, but it's not a very good idea. There's got to be a different way. The second way is to make the sample size larger. All right. Now think about what's going to happen here. Uh, the um, the sample size is in the standard error, and it's in the denominator. So as the sample size goes up, the standard error will actually go down. It will go down, right? And if that's going down, that will make the width of the confidence interval go down. Why? Because the margin of error is also going to lower in that situation. Okay. This is a much better idea. All right. This is a much better idea than the first one. The only thing that you really have to consider here is that make sure that it doesn't cost too much to do this. All right. Consider doing this if the cost is reasonable. Right. So if you're doing a survey and you want to go ahead and increase your sample size, well, it's probably not going to cost you that much more to do that, if anything. All right. But if you're a medical researcher and you want to bring in 50 more people, that might be that might be thousands and tens of thousands, hundreds of thousands of dollars to do that because you might have to give them experimental treatments or drugs. It's very expensive, possibly, to do that, and so you got to consider, the cost. All right, you got to weigh the cost with you know, with what you're doing here. Okay, but if you had to make the decision between the two, and cost wasn't necessarily a deciding factor, okay, you want to definitely do the second one versus the first. Okay, so basically what I'm saying here is that there's a trade-off between the amount of confidence and precision. The higher the confidence, the less precision we have. All right, because the higher the confidence, if you go from 95 to 99, you're making the interval wider. True, your confidence going up, but your precision is actually going down. Okay. So most industries have debated and settled on what is a good compromise between the amount of confidence and precision, and most have settled on 95%. All right. Okay. So everything that we just talked about is in general for all confidence intervals, not just the population proportion P. However, the next slides that we go over is very specific to the population proportion P and making a confidence interval for it. Okay. All right. So notice here that what we're doing is we're selecting the appropriate sample size. So how large should the sample size be in order to accomplish what we want to accomplish? So what we're going to do is that we're going to pretend that we're a researcher, right? And we want to go ahead and create a confidence interval for the population proportion P, right? Now you saw that in the last section in part 1 of 10.2, we read the problem and it says, here's our sample size, here's X, so on and so forth, and did some calculate. Okay, so true, that's how you go about calculating the confidence interval, right? But in real life, think about it from a researcher standpoint. Are you going to be able to open up a textbook and just somebody's going to say, well, your sample size is this. Go ahead and do it. All right? No. As a researcher, you got to figure it out. Okay, as a researcher, you got to figure out how large of a sample size do you need in order to do these inferential techniques. And so we're just going to go over one scenario, and that scenario is that we want to know how large of a sample size uh, do we need in order to create a confidence interval for the population proportion P. So ultimately, the researcher is trying to create a confidence interval for the population proportion P, but we need to know how large of a sample size do we need to do it, okay? And so we are just giving you an idea of what a researcher might, the steps that a researcher might have to do in order to figure this out, okay? So there is a formula, but instead of just giving you the formula and saying, magically, there it is, okay, I want to show you where it comes from. So reminder is that we have a confidence interval for the population portion P, and there it is. And the margin of error is this last half, right? And so where's there it is. So the margin of error is this last half, right? Anything after the plus and minus sign. And so to figure out the sample size necessary, basically you're going to solve for n. Okay, now I'm going to spare you the gory algebra, okay? But if you go ahead and take this formula right here, the margin of error is equal to the critical value times your standard error, and you go ahead and solve for n, that tells you how large of a sample size you need in order to create your confidence interval. Okay, and there it is. All right. Notice there are some squaring going on here. All right, here and here. Please do not forget about that. And so let's start with this, the critical value. All right, with the critical value, that is based upon your level of confidence. Okay, so your confidence level, and that hasn't changed. Believe it or not, what you get to do is you get to set your margin of error. Okay, and I'll show you how to do that. Okay, and it's really easy. You just kind of pick a number. Okay, but you got to be careful on what number you pick. And we also have to figure out what to do with p hat here. Okay, and so I'll show you all these steps. But they're pretty simple. Okay, they're fairly simple. So to determine the sample size necessary to calculate a confidence interval for the population portion P, first we must decide on the desired margin of error. The desired margin of error. Okay. And second, we must decide the confidence level used to create the confidence interval. Remember how that's given to you in the problem? Well, okay. As a researcher, we would have to decide on that, but hopefully we don't go against the industry standards. Now, in the problems that we're going to do here, that'll be given to us in the problem. We don't have to guess at it, okay? And the third is that we got to figure out how to handle p hat, okay? Now remember, p hat is equal to x over n, but we're trying to figure out what n should be, the sample size, right? We don't know what the sample size is, okay? So how are we going to handle p hat? We don't have n yet, okay? And so there's two ways to handle that. And you do this in order. You do this in order, all right? So you start with the first one. If you have the first one, okay, you go ahead and use it. If you don't have the first one, you go to the second one. Okay, so if you got the first one, you go ahead and utilize it. If you don't, you go to the second one. All right. First one says is that often a preliminary sample is done for a much larger study, and if a preliminary sample was done to calculate p hat, use it. So a lot of times a researcher will do that. Instead of doing the full-blown study, the researcher might take a quick little random sample that's kind of small, smaller than what's actually needed to create the confidence interval, just to get an idea where p hat and possibly where p might be sort of located. Okay, so so if you've done the preliminary sample, go ahead and use it. You could also use someone else's estimate for p hat from a different study if you trust what they've done. Okay, if they're defined exactly the same way. Okay, so you can do that. All right, so you start with the first one. If you got it, use it. All right, so if you have an estimate for p hat, go ahead and use it in the formula. If you don't, okay, so if the first one doesn't apply, if you didn't do a preliminary sample, you can't use somebody else's study, you go do the most conservative thing that you could possibly do. Okay, and that is setting p hat to equal to 0.5. That will maximize the sample size that we need in order to do the confidence interval. All right, it's the most conservative thing that we could do. So here's the question. Suppose a researcher wants to create a 98%, there's a different one, 98% confidence interval for the proportion of drivers below the age of 40 that text while driving. The researcher asks the statistician, how many people should she ask if the researcher wants the confidence interval to have a margin of error of 1%? Okay, so here's our formula again. All right, and let's start with p hat, right? Let's start with p hat. Well, often preliminary study is done, but was a preliminary study done here? Well, let's take a look. Doesn't look like it. Okay, doesn't look like the preliminary sample was done. So since the preliminary sample was done, it looks like we're going to have to set p hat to equal to 0.5. Okay, so what that's going to do is that's going to maximize this part of the formula. Okay, it's going to maximize that part of the formula. Okay, what about the critical value? The critical value depends on the confidence level, and since the confidence level was set to 98%, we're gonna make that critical value 2.23. All right, we haven't used that one before, so there you go. We're going to use 2.33 here. All right. The desired margin of error is 1%. That's what the researcher wanted. Okay. And be careful on this. Don't put 1 and square it. 1%, you got to change it over into a decimal, 0.01. Okay. You got to change it over to 0.01. And you can go ahead and figure this out. So I think we have all the pieces parts now. And so we got here, there's all the different pieces parts. I threw everything into the formula, okay? And I came out with a sample size of 13,572.25. Wow, sounds like a lot. It is, okay? So let's analyze this a little bit, all right? First thing is, can you sample 13,572.25 of anything? You have a sample size like that? No, sample sizes have to be what? A nice whole number. Okay, they have to be a nice whole number. This isn't a nice whole number. So that's a bit of a problem. All right. The second thing is that the 13,572.25, that's the absolute minimum that we needed. Okay, that's the absolute minimum that we needed, and we need a whole number. Okay, and so we need to solve these two problems. Okay, and the easiest thing I think that we're going to do, the easiest solution to this is the following: is that to solve both of these issues, always round up to the nearest whole number for n. This is the only time that you're going to round up. Okay, at least in this class. And so I don't care if this was 0.02. Okay, we're always going, because that's the minimum that we need. So we can't drop it down to 13,572. Okay, that won't satisfy the minimum requirement. And so what are we going to do? We're going to round up to the nearest whole number. Okay, so really the final solution here is actually 13,573. Okay, now that's a bit of a problem here. That seems like an awfully large sample size, right? That seems awfully high, and it is. Now, why did this turn out to be so high for this particular problem? Well, first of all, the confidence level was set to 98%, right? If we back this off a little bit, all right, say to 95%, that would lower the sample size necessary. So going from 98 down to 95, that's going to help things out a little bit. That's going to change the critical value a little bit, right? Okay. And it's going to take it from 2.33 down to 1.96. Okay, that's the first thing. Second thing is that we set the margin of error to 1%. And if you think about it, what that's doing is that you're asking for a whole bunch of precision. Okay, so if you set the margin of error to 1%, basically what you're saying is that you need that when you go ahead and collect your sample, okay, and you go get p hat, basically what you're saying is that you want p hat to be within 1% of the population proportion p, 98% of the time if we left it at 98%. Whoa, that's some precision, okay? And because of that, because of that uh, necessity to having such precision, it's going to increase your sample size greatly at that point. It means we're going to need to ask a lot of people, okay, sample a lot of people at that point. And then 3, we didn't have the preliminary p-hat calculated. Remember, we had to use 0.5, and that maximized that part of the formula, okay? And so all 3 of these things contributed to the fact that we had a very large sample size. So we're going to change some things around, okay? So there was the original question. Here's the modified question. Suppose a researcher wants to create a 95%. So instead of 98, okay, we're going to make a 95% confidence interval, okay? She does a small preliminary sample and finds that 25% text regularly while driving. Might be more than that, but we'll see. I don't know for real. Maybe somebody's done a study on this. I don't know. I have a feeling it's more than that, and I bet you it's very different for different age groups. But anyways, the researcher asked a statistician, how many people should she ask in the main study if the researcher wants the confidence interval to have a margin of error of 3%. So she's backed off on the precision a little bit. Okay, she's backed off on the margin of error. So notice what would happen here is that the critical value would change to 1.96 because of the 95%. We have an estimate of p hat. We're going to use 0.25. Obviously, we're going to change that into a decimal when we throw it in the formula. And then margin of error, we're going to set it to 0.03. Remember, not 3, but 0.03, right? We got to change that percentage into a decimal. All right. So we throw all that into the formula. And what I get is 800.33. Now look at the difference there. Okay. We had it over, I don't know, over 10,000 before, right? Now we got 800. A little bit more reasonable stuff here. Okay. Now, by the way, is that our final answer? Nope. Round up to 801. Okay. Round up to 801. That would be our final answer there. Okay. So this is just giving us an idea how researchers go about figuring out the sample size when calculating a confidence interval for the population proportion P. All right. Thank you for your time today.